Hey guys, welcome back to the channel. So from very long, it's been a curious question: what lies at the galactic center of Milky Way galaxy? So through the help of lots of research and estimations of our scientists, estimated a presence of supermassive black hole, or around 26,000 light years far from our planet. And 12th May 2022, that was a remarkable day in the human history when we got the first image of that supermassive black hole. So in today's video, we are briefly going to discuss the same supermassive black hole that is nothing but the Sagittarius A. So let's start the video. So if we try to understand what is Sagittarius A, it's the center of Milky Way galaxy. Technically speaking, a bright and a compact radio source in the galactic center of our galaxy. The whole Milky Way galaxy revolves around it. While astronomers have long been aware of this radio source in this area, but it was never entirely clear what was inside this area. So, as we know, the event of horizon don't emit any kind of light, so that's why we were never able to see this spot through our optical telescope. So that's where radio telescopes came into the picture. So we'll see the working methodology of the radio telescopes and how come these collective set of radio telescopes, what we call as event horizon telescopes, come into reconstructing these pictures of these supermassive black holes. Either it's M87 or it's Sagittarius A. Hey guys, so on 10th April 2019, we got the image of supermassive black hole M87, and in this year, 12th May 2022, we got the image of Sagittarius A, which is also a black hole that is the center of our galaxy, around which the everything of entirely whole Milky Way galaxy revolves around. Now the question arises these are basically a black holes. Either we are talking about Sagittarius A or M87, and we say in the center of the black hole's event of horizon EH, nothing can be emitted back once they come into, not even the photon particle. So if the photon particle is coming inside the event of horizon, it can't be emit back. So how come we are getting these pictures? So first of all, we are not getting the optical image. We are getting the radio signals, the strength of the radio signals through the help of radio telescopes. So what we call EST, event of horizon telescopes. So what basically EST, event of horizon telescopes, is like a collaboration of radio telescopes at different part of Earth. Now we will come across this, but we'll see how these radio telescopes works. So basically, astronomers just to detect any radio sources into the space, they use these radio telescopes. So they are basically a disc designed in a way they will grab the radio signals coming from the certain direction, converts them, all of those radio signals, into a radio receiver RCD. Now here these discs are also designed in a way that these peaks should be lined up at the same time. So what I mean to say is, suppose these are the input signals coming, so what the radio receiver is receiving is in the same way, all the peaks are coming at the same time. So in this way we are getting the stronger radio signal and basically a sharper image. So this is nothing but a constructive interference. Now suppose if these signals are coming from different direction, we can draw different diagram. Suppose these signals are coming in this way. And these are the input signal. All these are ending up in this way. So this is known as a destructive interference. Now these radio telescopes are designed in a way that they should accept these radio signals making the constructive interference and neglect or cancel this destructive interference. So that means they are designed in a way to grab the radio signals from certain direction. So how come they are calculating this? So actually they are evaluating this direction through angular resolution. So angular resolution theta equal to lambda by d. So what this angular resolution is? So this angular resolution is basically from where the minimum angle from in the directions, the approximate angle between the directions where the constructive interference Ci begins and constructive interference ends. So I showed you what the constructive interference is. So the angle between those directions from where the constructive interference begins and ends is known as the angular resolution. So it is equal to the wavelength of the input wave coming. So this is the wavelength and the diameter of the disc. So suppose this is the radio telescope. So this diameter is d here. Now if we see the size of supermassive black holes and the distance from the earth. Now if we go through this concept, so we need a too much big radio telescopes to grab the whole image of the supermassive black hole, almost the size of earth. So almost size of earth, this much huge radio telescope we need to grab the whole picture of supermassive black hole at a time. Now this is not possible. So here comes one concept comes into very long baseline interferometry, VLBI. So this is a concept in which our scientists has placed these radio telescopes at several parts of several corners of this globe and grabbing the images at different time and reconstructing the image through that. So we will see this very long baseline interferometry. So let's start with the VLBI. Now to get the enough angular resolution, that angular resolution lambda by d we have seen. So now to get the enough angular resolution to get the whole image of supermassive black hole, we have seen we need the that much big radio telescopes all around the size of this will be equal to the size of Earth, which is beyond the human capability. So in order to overcome this challenge, we came with the concept of VLBI, very long baseline interferometry, where they have constructed small radio telescopes at several parts of this globe, and they are grabbing the radio signals, and all those information they are collectively they are all through the collective information of all these radio signals, they are reconstructing the image of the supermassive black hole. So these radio telescopes collectively working same like this enormous radio telescopes. So in this way, we are getting the images of these supermassive black hole, either it's M87 or Sagittarius A. So basically, Very Long Baseline Interferometry is a network of space and Earth-based radio antennas that combine to create the equivalent of a telescope with a diameter more than 2.5 times of Earth diameter. The powerful system provides astronomers with extremely detailed images of distant astronomical objects. I will share the link in the descriptions where you can see the informations regarding VLBI and the network station situated all across the globe. So this supermassive black hole Sagittarius A lies at a distance of on around 26,000 light years from Earth. Sagittarius A is the second supermassive black hole directly imaged after M87. Even though Sagittarius A and M87 were imaged at the same time, the data for Sagittarius A black hole posed a greater challenge. The processing took on around 5 years and the analysis was made difficult by the radio emissions. Why? Because it was changing in the order of minutes. Sagittarius A estimated to have a mass of on around 3.7 to 4.3 million solar masses. So now what is the solar mass? Solar mass is the weight of sun, that is all around 3,33,000 times of earth mass. For us it might be a simple image, but to image Sagittarius A, the Event of Horizon team linked together 8 radio observatories at 6 sites around the whole globe to form a single virtual telescope. More than 300 researchers and 80 institutes on around the world had participated in this Event of Horizon telescope collaboration. So that's all about Sagittarius A. Hope you like this video. If you like it, please do hit the like button. If you have some piece of advice or if you want to tell me where I can improve myself, please do comment below. If you like the content on this channel, please do subscribe this channel, because as per YouTube analysis, 90% of the viewers don't subscribe the channel. So please do subscribe the channel. And if you want to connect with me over a social media platform, I will share my profile link in the descriptions. You can connect me over there. So thanks for watching.